Do we want to like just go over it, or do we want to go over it while we're going through the group quiz?
I say we just go over it while we do the quiz, unless anyone has any objections.
It's fine with me. It's all the same questions from the review, so.
I mean, did you guys have any questions you just really didn't get on the review?
Really get or don't get?
Don't get? What's the difference?
There was a couple for me.
Okay. Well, we can just do it as we go, I guess.
Okay. So the first one, given the 90% confidence interval for the mean heart rate, which of the following is the best interpretation of the confidence interval? The first one, we're 90% confident.
Yep.
That's what I got.
Cool.
Number 3. Sorry. Researchers at the University of Mississippi want to determine whether the reaction time in seconds to no-go stimulus in males is different from that of females. The researchers selected 20 females and 15 males to participate. The no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference in the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see if they're
Oh.
You lost him. What did you get for that one, Darby?
I said that it would be no because the sample sizes aren't large enough.
Okay.
Wow. Sorry.
No, you're good.
Okay. I don't remember what I was reading. I got yes, the distribution of the mean sample is normal since the data has determined to be normal.
Oh, I said no because okay. So wait, what did you get, Joel?
Which one did I look? I got the same one as Christian.
Okay. I was doing this at 11 o'clock last night, so.
Well, so was I, Darby.
But were you going on 3 hours of sleep too?
I was not, but I did have to get up at 4:45. So
Why?
because we're getting a ton of snow out here in Colorado, and we only have one car that can get around in the snow, so I had to drive my dad to work so we could have the car for today. But anyways, that doesn't have to do with... The reason I picked this is because I thought if you do a QQ plot and they look normal, then you can assume that the data is normal, so that's why I picked that one.
Okay. Number 4 says, of the 4 types of confident intervals listed below, which one is appropriate for this experiment? Wouldn't it be the confidence interval for you when sigma is unknown or whatever that sign is?
What else?
I picked the different one. Because you're comparing 2 different means, so I said it was confidence interval for the difference of means using independent samples.
Oh, yeah. Okay.
Independent, though?
What?
Are they independent or are they dependent?
Right, because just because a female picked doesn't mean that her male counterpart's gonna be picked. We have two sets of means, female means and male means, but there's no connection between how they were chosen. So.
Okay.
But argue with me. I don't want to.
No, I don't really know. Because I guess you're right. It's not dependent on what they pick or whatnot. Makes sense. Okay, so if I have a researcher interested in estimating the savings balance of a customer at a large bank, she obtains a savings account balance at a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of the bank customers is found to be so-and-so. Which of the following will produce a confidence interval with a small margin of error than this 95% confidence interval? I said that you compute the 99%.
I said obtain the balances of 90 bank customers rather than 30.
That's what I said. Because
Okay.
the large sample group, the
The smaller the margin of error.
Okay, I'm with you guys.
Number 6, the factory makes propeller drive shafts for ships. Quality assurance engineers at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measure the lengths, and find their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate 95% confidence interval for the true mean length of the shafts. This one took me forever, but I think I got... What was it? I got 99, the first one, 998.040 and 1001.960.
Dang it, I got a different one.
Ah, dang it, Joel.
What'd you get, Darby?
I got the first one, oh my goodness, 1,960.
I don't remember how I got it either, that's the problem, or I would tell you.
Isn't it just so it's the 1.95?
96, yeah.
96. So it's like 1.96 times times 2 because there's no n, right?
Mm-hmm.
No, there is an N. The N's 4.
Where's maybe
She randomly selects 4 drive shafts.
that's why. Okay. I didn't see the n. I overlooked it. So okay, I'm with you guys.
Okay. 7 steps to assess the accuracy of a laboratory scale. A standard weight that is known to weigh 1 gram is repeatedly weighted a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with the unknown mean u and standard deviation 0.01. How large should n be so the 95% confidence interval for u has a margin of error of plus or minus 0.0001? I got 38,416.
Yeah, that's what I got.
Yep.
Hooray. That one I stared at for so long, and I went back through the notes. I was like, how the freak do you do this? But finally I found the formula.
Okay, so number 8 says the mean area U of the several thousand apartments in the new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are. So wouldn't it be the first one?
Yes.
That's what I got.
I got.
Oh. Well, that snow must be messing with his connection or something.
Yeah. Probably.
Should we continue?
Sure. We can just catch them up, I guess.
Okay.
So in a statistical test of hypothesis, we say data are statistically significant at the level of significance if, isn't it the first one?
Mhm. That's what I put. Okay, so 10 says the group of statistics students wants to determine if students in some apartment buildings are getting better grades than other students in other apartment buildings. They collect GPAs from an anonymous random sample of a size 15 from each 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample's standard deviation are nearly equal. Can they use a ANOVA hypothesis test to answer this question? I said yes, because the data is bell-shaped with no outliers.
So that's it too. Okay, so a medical researcher is working on a new treatment for a certain type of cancer. The average survival after diagnosis for the standard treatment is 2 years. So the null hypothesis is the average survival time after diagnosis is the same for the new treatment and the standard treatment. In the early trials, she tries the new treatment on 3 subjects who have an average survival diagnosis time of 4.5 years. Even though the sample is small, the results are statistically significant at 0.05 significant level. Consequently, she rejects the null hypothesis. In the future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with a particular type of cancer. So I said committed a type 1 error.
Yeah, so I got 2.
Type 1.
Okay, so 12 says if the level of significance, whatever that symbol is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? And this was one that I was a little confused on, so.
Hi again, sorry.
Yeah.
Having issues today, I don't know why. I got, for that one, by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yep, that's what I got too.
Okay.
And then, so do you want to go? Okay, so Christian, for 9, we discussed that alpha equals 0.05.
Yep.
And then for 10, yes, it is enough because the data is bell-shaped with no outliers.
Weird. On that one, because on that one in the homework, there was that part of the answer was longer. It said it is enough that the data are bell-shaped with no outliers, and the sample standard deviations are nearly equal. Because that's important for an ANOVA test, and it's not part of that answer, but I think we'll just stick with it.
I think she probably just forgot it. Maybe.
Yeah. Sorry, I'm back on number 9. I didn't get that same answer. I got when the p-value is less than whatever that symbol's called. Because it doesn't have to be 0.05, it just has to be less than x.
Okay.
Okay.
Does that make sense?
Yeah.
Okay. So then we got 10, and then 11 committed a type 1 error.
Yeah.
Okay, we just did 12. Okay, we'll do 13.
Sorry.
You're fine. The nicotine content in cigarettes of a certain brand is normally distributed when mean a known standard deviation of 0.17. The brand advertises mean nicotine content of cigarettes as 1.5, but measures on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is the evidence of the mean nicotine content actually higher than advertised? To answer this question, that's the hypothesis. At 5% level of significance, you conclude that you should what did you guys get for this one? I was kind of confused.
I did fail to reject. Originally I said reject, but then I realized that if you use the numbers and get a z-score, it's way below. It's way above 0.05, so.
Okay, so you just have to.
Yeah, that's what I did. I found the Z scores.
And you got failed to reject?
Mm-hmm.
Okay.
Cool.
14 says he would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group. And test if those means are different. What is the correct statistical procedure? I did independent sample t-test.
Yep.
Yep.
Okay, so 15 says an educator is interested in academic achievement by males and females with similar academic support systems. She decided to use brothers and sisters raised in the same home. Furthermore, she decided to only use brother-sister pairs when they are next to each other in sibling order. She uses a hypothesis test based on independent. Should she use a hypothesis test based on independent or dependent sampling?
I said dependent sampling. If you select a brother, then you're going to have to select his sister.
Mm-hmm.
Yeah, that's what I got.
Me too. Okay, so a soil scientist collected random soil samples from a field to measure the dissolved organic carbon level of each sample. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open the data file, use the information to answer the question. I said, of the 4 types of confidence interval listed below, which one is perfect for this situation? I said, the confidence interval for the mean when the standard deviation is unknown.
That is what I picked too. Although I wasn't real sure on that one, but that's what I thought.
Yeah, that's what I put.
17 says, which of the following is the 95% confidence interval for these data? I got D, 11.168 and 15.217.
Mm-hmm. Okay. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. We want to know if there is a difference in means listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York, Group 2. Create a 95% confidence interval for the true difference of means listing prices between the two cities. Open the data file and use the Hummers in LA and New York. And so I thought like this one was like the first one we did, so I said that the confidence interval for the means is when the sigma is unknown, or the standard deviation is unknown.
And I again picked independent samples because you have two different means you're comparing, but there's no connection between them.
Oh, yeah, that would be the one. My bad.
What'd you get, Joel?
Well, I got dependent, but
Oh dear. I was a little shaky on whether they were dependent or independent, but
Well, one's not going to affect the other.
right, because if you pick one car from Los Angeles, buying the next in New York, there's no pairing that I see.
Okay.
okay, we'll go with independent.
Joel's gonna be right. Just watch. 19 says, which of the following is the 95% confidence interval for the true mean of listing prices between the two? I got C, negative 423 and 5417.
Yep.
Hooray.
Okay. Alright, so many studies have suggested there is a link between exercise and healthy bones. Exercise stresses the bones and causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups, control with no jumping, a low jumping group, and a high jumping group. After 8 weeks of 10 jumps per day, 5 days per week, bone density level of the rats was measured. Rats were selected at random. For 3 groups, researchers would like to determine if the mean levels of the bone density are different between the 3 different groups of rats listed above. The level of significance 0.05. Open the data and answer the questions. So I got, for the first one, what's the correctness hypothesis test? I got ANOVA.
Yep.
Me too.
Hey, we agreed on something.
Calculate the test statistic. I got 7.978.
Me too.
I got something different, but I think I calculated something wrong. So
Okay.
I'm pretty sure my p-value is also different.
Okay, so for the p-value, I got 0.002.
Me too.
Okay, so 23 says, which of the following best expresses the conclusion of this test? Use the level of significance of 0.05.
I got there's sufficient evidence to conclude B. There's sufficient evidence to conclude that bone density of at least one of the groups is different than the bone density of at least one of the groups.
Yep.
Okay, so 24, I'm not going to read the whole long thing.
That's okay, Joel.
So for 24, I got dependent sample test.
Hey, me too.
Okay,
Yep.
good. I was worried for a second.
25, I got 1.685, which is A.
Me too. And then, so 26, I got 0.096 for B.
Me too.
Yep.
27, which of the following best expresses the conclusion of the test? Use a level of significance of 0.10. I don't know what I got. Hold on, let me look. I got B. There's sufficient evidence to conclude there is a difference in the cost of tickets purchased.
I got insufficient because isn't the level of significance higher than?
No, because the level of significance is 0.1.
Because you would round. Okay. So you got B?
Yeah.
Okay, that was my fault. I didn't think about the rounding thing. I was like, oh, they're not going to trick us like that, so I'll just... I already did. Okay, sorry, that was dumb.
Okay.
I think we answered them all right.
Uh-huh.
Are you with us, Darby?
Yeah, I'm tired.
Should we submit?
Yeah, why not?
We got 13 wrong, and that's it.
What's that? Which one was 13? Oh, okay.
Oh, and 12. Sorry.
Yeah, 12?
I didn't get 12 wrong. 12 is D, right?
Yeah.
Did you get it wrong, Darby?
Apparently so.
Nice.
13. Huh. So that's interesting to me. Because I did the math and Darby did the math, but apparently we both did our math wrong.
Apparently I need to study.
Hooray.
Me too.
Well, one's not bad. Other than Darby who missed 2. That's okay, I missed 2 last time when everybody else missed 1, so.
Dang it, that means it's my turn next time.
Good luck, Joel.
Mm,
Thanks, guys. We're on for Tuesday at 7:45.
yep.
Yeah.
All right. Bye. Thanks.
Bye, guys.